First thing I'm going to cover is transferring fuel. Whenever you transfer fuel, gasoline, or any non-conductive product, for example, water conducts electricity. But if you have fuel which is non-conductive, if you transfer it from one container to another, it's going to generate a charge. So the first thing you have to do whenever you transfer fuel to an aircraft or to your ground vehicle or anything else, you have to hook up a ground cable. They used to call it ground cable, now it's called a bonding cable. We used to have to go from electrical conductivity from the aircraft to the transport and so forth, and then to ground. They've changed that, and now all you have to do is go from the aircraft to the pumping unit, and it's bonding. One of the things you have to do if you want an FBO, or the thing is to make sure that you have electrical conductivity. Everybody's out there grounding the airplane or bonding the airplane, but unless you can be assured that you have conductivity through the bonding cable, it's not going to help you any. So you need to, on a monthly basis at least, check the bonding strap for continuity. A lot of times you'll have these reels that retard and so forth. Those things are notorious after a very short time of getting corrosion on the excuse me, surface, and then once they get corrosion on there, you don't have conductivity. So you have to check the conductivity of your bonding equipment monthly. Grounding is not necessary. You always use a bonding strap when refueling with cans or defueling aircraft. I was afraid you'd ask that. There's no good answer there. At Shell, excuse me. Well, at Shell, what we would do is to a bonding cable, you had to have a metal strap down in the container. A lot of people don't do that. Usually you can get away with it if you're not doing much more than a 5-gallon can. But if you're doing a large drum, yes, you should put a metal strap up in there to dissipate the charge.
The metal strap just goes into the gasoline?
Yeah, it goes into the gasoline and then to the unit.
So it does no good to touch the container on the fuel, on the filler.
Well, it does. But the problem is if you don't get good contact and so forth. For example, if you're refueling your car, that's how it works, is the hose is grounded and so forth. But if you don't have, put it in there and leave it set so it has good contact, then it's worse yet, because if it's a ways away, that'll arc right there, and that's where you get your fire started. Now, one of the real problems comes in is, why doesn't diesel fuel or Jet A have a problem? It doesn't blow up because at the interface between the nozzle and so forth, it's too lean to burn. So for a fuel to burn, you have to have just the right air-fuel mixture. It's from about 10 to 20 ratio. If it's leaner than that, it won't burn. For example, if I had a container of gasoline here, if I put a spark plug down in here and arc it, nothing's going to happen. It's too rich. If you do it with diesel fuel, it's too lean. So that's why when we're refueling our diesel cars or trucks, it's too lean at the interface. But if you're doing a gasoline, it's too rich, so there's too much fuel for a given amount of air. That's why a few years ago when Oldsmobile came out with their diesel, they had, what you have to do in the wintertime is just put a gallon or two of gasoline into your diesel tank. That's when they got into a problem because it entered into the explosive range. So you've got to have it outside the explosive range. Okay, the biggest question, and one that just bugs me to death, where do you put a bonding strap? When you're bonding your airplane, where do you ground it?
Exhaust pipe.
Exhaust pipe. A lot of people complain that that scratches up the chrome stacks. But it's just totally beyond me that we have all these safety devices, but they put out these high-priced airplanes, especially now that we're getting into fiberglass body ones, but they don't designate a grounding lug. There should be a grounding lug on every one of them. So what do you do if you have a plastic airplane? You get a voltmeter out and find some place to ground it to. So there are a lot of things you really need to do, and one of them is you need to find a grounding lug for your aircraft. Also, if you're doing the, while we're talking about dangers of refueling, you need to test all of your motor gasoline, MOGAS, for ethanol. This is, of all the dangers, that's one of the biggest. So how do you test for ethanol? Put water in it. Now, that works fairly well. You have to have a graduated beaker, and you put in, say, 10 cc's of water. And then you fill it up with fuel, shake it up, and if the level goes up or down, that's an indication. The latest one is people use food coloring. Now, if you, again, it has to be the water-soluble food coloring. But if you put food coloring in ethanol containing fuel, it will discolor it. Because ethanol is polar, it absorbs water. If you put it in straight gasoline, it doesn't discolor it, it just drops to the bottom. And before you do that, I'd play around with it a little bit, but it does work. I've tried it several times and it works well. But you have to have water-soluble food coloring. One of the other problems with MOGAS is storage stability. Avgas is good for 6 months to a year. Your motor gasoline you should use well within 6 months. Well, there's a difference, but as far as storage stability, no. The main difference between the winter blend, and that difference has decreased a great deal in the last few years because EPA has limited the vapor pressure that you can have from motor gasoline. It used to be in the wintertime, they had all of this butane. It has good octane. They love to put it in fuel. And so they would really load it up in the wintertime. Now, because of evaporative losses and so forth, they're not. And so now you're seeing 7, 8 read vapor pressure fuel before you get 15, 16. So no, the winter blend really shouldn't be that much different than the summer blend. It's just a small change now.
How can you get rid of old gas?
How can you get rid of old gas? Do you have an old tractor? No, if it's gummy, you want to keep it out of your carburetor. What I do with it, like I said, I've got a bunch of old John Deeres, and they were designed to run on diesel fuel, you know, and so I just blend it off in there. But if you can smell it, you don't want to use it. I used to tell everybody to do a smell test, but oh no, HSC said you can't do that. You can't have people smelling their gasoline. That's a health hazard. So don't go around sniffing tanks. It's not good. But if you walk by the tank and it goes, whoa, don't use it. But like I said, a good rule of thumb is you need to use the fuel up within about 6 months. Probably should have put some vodka in here. It'd probably do a lot better. Avgas is good for a year. Okay, one of the things now, this is much more for FBO'S, people that are in the business. But if you do have an FBO or if you work at one or so forth, it's very important when we have accidents that you have more or less a chain of command so you can see and prove that what you sold was on spec. So you need to take and retain fuel samples for all shipments. Now, most of the time, we'll keep them for about 6 months. But for every time you bring in a thing, we usually take at least a quart or a gallon sample so you know what's going on. Check all water drains and some fuel separators, and you should do that most of the time daily or whenever you're doing a shipment. We went into a FBO a few years ago, and he said, no, I've never had a filter problem or anything else. I said, well, can we drain your filter separator? He said, oh, yeah. Well, I knew when we had to get a 4-foot pipe wrench just to turn the valve, we had trouble. And he had all this rusty water coming out. He said, well, the filter's never plugged, so we opened it up, and he didn't have any filter elements in it. So, yeah, he didn't plug it. You have to inspect each refueling unit, change filters periodically. Also, you need to monitor the pressure drop. You should do that every time you're pumping, almost every day, so that if it starts to plug, the pressure drop should go up. Like I said, if you have zero pressure drop and have for the last 10 years, you need to go check it, see if there are elements in it. Here's the other one. You need to check the continuity of your bonding strap. Get out there with a volt ohm meter and so forth and start checking. Develop and train all personnel on safety procedures. How to handle the fuel, what's the difference. The biggest problem that we have as far as accidents is still misfueling. You know, people would see something like a Turbo 210, takes turbine oil. No, it doesn't take turbine oil. So you've got to make sure that people know what to put in it. It sounds like a really simple thing, but it's still, what happens is still, especially if they're busy and so forth, people put in the wrong fuel in the wrong aircraft. And that's still a huge problem. Develop an accident plan. What do you do if you, or say, are fueling an aircraft and there's a crash? What do you do? If you got an FBO and somebody that you fuel takes off and crashes, what do you do? Do what?
Turn off the master switch and turn off the ignition.
Well, of the plane, yes. But if a plane has an accident from your FBO or from one around there, you need to shut down the whole FBO. Because if you sell gasoline and it causes an accident, that's negligence. If you sell it to another one, that's criminal negligence. Huge difference. So for your FBO and everything else, for those of you who are working FBOs or are friends with them, they have to have a procedure for if there's an accident. What to do if there's an accident? Shut down the fuel system. I know everybody says afraid of the FAA, but if you have an accident, the FAA is your friend, and they're the ones you want to call. So forth. You got to take, that's when you have to take fuel samples and document time and location. You take it from, if you can get it from the plane that crashed, otherwise you need to take it from your refueler and your tanks. What do you do with those samples? You take them, do not send them. You have an employee, you put them in your car, you have to develop a train of authority that the people that take the samples, take it in and so forth, so they know that no one can contaminate them along the line. What lab would you use? Is anybody here working at FBO? Okay. The FBO, your local FBO, you need to make sure that they have a way to do this. You got to test, retain the samples. You need to call the FAA and so forth, discuss results with them, and if they're okay, you can reopen your fuel system. Okay, autogas is a big subject. It can be safely used in aircraft, but there are a few concerns for pilots. Again, the biggest problem is ethanol. Ethanol well, first, it's very corrosive. It's a very good solvent, and it will corrode your tanks and just about everything in the aircraft. It also will attack most rubber elements. Most MOGAS takes up to 10%. So you've got to, if you're going to do MOGAS, the biggest thing you're going to have to do is find a source that can guarantee you no ethanol in the fuel. And that's not an easy thing to do. So forth. It can be very difficult. Ethanol-containing MOGAS will attack rubber systems. For example, University of Illinois were demonstrating how to fly, that they could fly on ethanol. And they had a 206. It looked like a flying corn cob and so forth. And they decided to fly it on pure ethanol from the University of Illinois in Champaign all the way down to Atlanta. They had to change the float 5 times to get there. So it will just attack rubber, floats just go away. So now that was pure ethanol. 10% will do much the same thing. So it's very, very critical. Ethanol absorbs water and so forth. Causes a lot of, and again, the higher the altitude, the more problems you're going to have. It also has a much shorter storage life. They say about 3 months compared to 6 months for normal autogas. And it can disarm filter separators in the fuel handlings, and there are other problems. So if you're going to run MOGAS, again, you have to do the STC for it, but the big thing is you've got to find a source for ethanol-free avgas, or MOGAS. Any questions on how many here have used MOGAS? A few of you have. Again, there was a lot of scares at first, but the main thing is the ethanol scare. Again, for the FBO, find an ethanol-free source. They have to test every shipment. Are there any FBO'S here that sell autogas?
Yeah, right on the field it's labeled AUTOGAS.
Okay. And again, they have to test every shipment for ethanol, and again, it's very critical they take and retain samples of every shipment and document every receipt, post-accident investigation, and so forth. So again, there's a lot of extra responsibility with MOGAS. For pilots, you must purchase an STC for the aircraft and follow all the parameters. A lot of people figure you can just put it in. Most aircraft, it's really not a big deal, especially for the high-winged aircraft. Must check for every purchase and so forth, and use the fuel with less than 6 months and follow safety procedures. Okay, so what's going to happen with autogas, or with aviation gas? Anybody have any ideas?
Why were you?
Oh, yeah, yes. Again, it pretty well is a total crapshoot. The big thing is, the first question is will 100 low lead go away? There is no scientific proof that it represents a health hazard. Everybody says it's higher lead levels. No. They've done a lot of studies and they've never seen any higher lead levels in people that are near avgas than people that are away from it. In fact, DuPont ran a study, now this is 30 years ago, when lead was just going away from AUTOGAS, that they tested the blood level of taxi cab drivers in New York that are in it all day long. And they tested the lead level of a tribe of people out in the middle of the bush out in Africa that had never seen a car, and there was no difference. So it doesn't get in the blood level, but it is one of those, they've heard of lead poisoning, so lead must be bad. There's no scientific proof for it, but again, that doesn't really make any difference. The government and EPA has never really let facts interfere with their thinking. It slows down their work process way too much. But there are several lawsuits. The one in California was settled, which they paid it off, but they'll probably come back. It is, excuse me, if it does go away, unleaded fuels are kind of doomed. Big question is, what will it replace it? Right now, they are testing 4 100-octane fuels, unleaded fuels. 2 of them are from Swift, 1 of them is from Shell, and the other, I think, is from BP. There's a lot of problems with it. Again, the first choice really would be to come with about a 94 octane, which would be the present fuel, just taking the lead out. That would work in about 90% of the aircraft out there. The big radials, no. Well, some of the big radials, a lot of the big radials were certified on 8087, but the 100, 130 octane ones, no, you're not going to satisfy them with that. How many aircraft are certified on 115, 145? There were only 2. The rest of them are certified on 100, 130. Second choice is 100 octane leaded fuel. Again, the big problem will be what changes will that do to the metering? What difference will it have? For example, the GAMI has one, but it's very high aromatic. Is it going to dissolve your fuel filters? Is it going to dissolve fuel lines and everything else? And will it meter the same? Because knocking and everything else is very much dependent on how it's metered and so forth in the engine. The third choice is a 2-fuel system. Again, this is sort of probably the best we can do if they want to get rid of lead. If they want to use some common sense, it would be to promote MOGAS for most of the 8087 and also most of the other naturally aspirated ones, and then go to leaving 100 low lead in. That way they could reduce the lead and so forth. But like I said, common sense is not something that we want to do. The first problem that we have with unleaded fuel is exhaust valve recession. Anytime you overhaul an engine, and this is just about any of them, the lead tends to coat out the exhaust valve. And when it coats it out, it keeps it from sort of hammering in. You take the lead out, it tends to hammer in and more or less eat through the exhaust valve seat. Again, part of this is air cooled. It just doesn't keep the seat cool enough. And it's like a machining process. It just machines the exhaust valve right into the head. They've had this in automobiles, but again, they have water-cooled engines. And they also have hardened seats, and they've gotten by with the problem. Aircraft, they've not really gotten rid of, they put in harder seats, but it's still, especially if you're running it hard, it's still going to auger in the seats. If you have a aircraft that you run on motor gas, you really should break it in on some 100, 130. At least 25% for the break-in period. This will help you, to seat the valves and make sure that you don't have valve recession. One of the interesting things is there are about 4 octane ratings. For automobiles, we have the motor and the research. In aviation, we have the lean and the rich. Now, the lean rating in aviation and the motor octane are very similar. It's just a conversion chart, so they really are the same procedure. But when they developed for automobiles, they developed the rich or the research rating, and then some smart ass went out and did a correlation and found out that actual cars didn't really correlate well with the rich rating. So they changed the conditions to the motor method, which actually tended to correlate much better, but they kept the 2 of them anyway. The same thing's true in aviation. They had the lean rating, but because of the supercharged aircraft during World War II, they came up with a rich rating so that it better correlates to aircraft. But unfortunately, if you run a rich rating octane number on unleaded fuels, it just doesn't work. It's an inflection method, and it does not correlate well. You can get a number, but again, it's kind of meaningless. So we're back down to just the lean rating, and the lean rating doesn't really relate too well to the big engines. One of the other things, and this is a bit of a history lesson, when they rate engines, what they do is you would think they would have a reference fuel that had exactly 100 octane and 100 and 130 octane, but they didn't. They just went down to the local FBO and bought some 100, 130. And way back when they had high leaded fuels, the high lead fuels, they would let it up until it would meet the lean rating, and then the rich rating was usually quite a bit higher. When they went to low lead, they would let it up until you met the rich rating, and then the lean rating was always there. So when they rated these engines, most of them were rated on something like 105, 132. So when you're sitting there going, okay, we have 100 octane fuel, you're actually almost 5 numbers lower than the reference fuel on which the engine was originally rated. And when they rate these engines, what they do is they take them out and they fly them, or they usually do it on an engine stand, and they will rate the engine, and they'll keep advancing the timing until you get to knocking. That number of degrees usually gives you the margin of safety. So every engine is designed to have a margin of safety on the fuel that it's rated on. And like I said, in most present day engines, that margin of safety is about 5 numbers down. Now you add that to the fact there's a thing called lead bonus. So if you had 100 octane leaded fuel, it's going to knock significantly less than 100 octane unleaded fuel. So everybody's going around looking for this magical 100 octane unleaded fuel, but there's still a huge margin, lost margin of safety in the present day engines. Knock in, has anybody tried to or heard knock in an aircraft engine? You have? It's not really a good deal. When you, in fact, when they rated the engines way back in World War II, they'd take a multi-engine out and they would take it out and at night and watch the exhaust. And if it had smoke rings, that's when they knew it was knocking. And then once it starts knocking, you have just a few seconds till it goes into pre-ignition, and then right after pre-ignition, the engine goes away. Does everybody understand what knocking is? Okay, you have your 4-stroke cycles. You know, suck, squeeze, bang, and blow. Easy way to remember it. On the suck, you pull the intake air and fuel in. Valves close, you then compress it. Now, once you get to the top of the compression stroke, a spark plug or 2 spark plugs will ignite the air-fuel mixture. Now, most people just think it's instantaneous. Well, almost instantaneous, but if you look at it, it's a burn front. It goes out from the spark plugs to the different parts, and the further away it is, the temperature and pressure rises very quickly as that flame foam goes around. If you don't have enough octane, the end gases, the furthest away from the spark plug, will actually auto-ignite, like a diesel, which is a compression ignition. And so they'll just sort of explode. Now, what happens is so you're now trying to compress a slightly burnt mixture, and the peak temperature goes up very quickly. Now, if you have a automotive engine, the liquid cool will keep it, all of the different parts, especially the exhaust valves, from getting too hot. It retains the same temperature. In an air-cooled engine, the temperature of the exhaust seat goes up relatively rapidly when it starts knocking. Once you get to a point where the valve edge is enough to auto-ignite the engine, now when you go through the compression stroke, it will actually ignite, act like a glow plug, and will ignite the fuel and air. Now you have a piston that's trying to compress a burnt mixture. And once you get there, it's called a death rattle. Because once you get to pre-ignition, your engine is not going to be around for very long. And in fact, when they were doing these tests back in the World War II era, they said they had like just a few seconds from when they saw knock to when they had to shut it down or they had to replace the engine. They did these in multi-engine rated aircraft, so you could have it in just one engine and the others would bring you back. But if you got a single engine Cessna out there, you get up and it gets into the death rattle, you're pretty well better have a nice place to land because you're now in a glider. So it's a very, very hairy operation, and we're sort of living on the end. Aircraft engines, especially air-cooled ones, and they're almost all air-cooled, do not tolerate knocking at all. Okay, any questions on fuels? Yes?
MMO, they used it in Korea a lot, and added it to the fuel.
Uh-huh.
They're bigger radials. I add it to my auto fuel that I get that's non-ethanol.
Uh-huh.
Any thoughts on that? I know a lot of the older airplanes, they recommend it. Mine's at 48.
Yeah, the question is on Marvel Mystery Oil. We've done a lot of work on it, and basically, I've never seen data that proves either way. I've talked to thousands of pilots that swear by it. As long as you don't put too much, I've never seen any problem with it. But a lot of pilots swear that it got rid of their intake valve sticking. Now, if you have exhaust valve sticking, a lot of people have gone to TCP. TCP is the tricresol phosphorus will actually combine with the lead during combustion, and it goes from a tacky deposit to a flaky deposit, and it'll work the deposits out so you don't have a sticking valve. Any other questions? Okay, I've got a few minutes here. I'm going to run through lubrication. How do you break in an engine? Run it hard. What oil do you use? Break-in oil. Man, this is a smart group. I don't know why I came here. You follow the engine manufacturer's recommendation. Because they're the ones that will warranty the aircraft. And they have different recommendations. Now, if they have no specific recommendation, and again, for example, Lycoming says you can break in any of their turbocharged engines on gaseous dispersant oils. But Continental said you should break all of them in on straight mineral oil. So you need to go, and whoever's warranting the engine is ask them what they want. If there is no recommendation, what I recommend is that you use mineral oil on all non-turbocharged engines. After run-up, again, now if you buy a factory one or from a large rebuilder that has run it on the dyno, you can sort of skip this step. But if you're doing it yourself, run it up and so forth, do your initial check flights and so forth, make sure that it's not leaking oil and so forth. Usually it'll take you about 5 hours. On the initial flight, I usually stay close to the airport. I'm a chicken, sorry about that. But anyway, then change the oil after about 5 hours. Run the engine for about 15 to 20 hours, change oil again, and then you come in for the third oil change, and you go additional 25 hours, and then drain the oil. Now, I always check the filters when I do this. I don't do oil analysis. If you do oil analysis on the first few oil changes, it's going to scare the daylights out of you. There's just going to be a lot of iron in there. So don't do that. But do check the filters. If you cut the filter apart after this third oil change, and there's still a lot of iron in it, if you can read the part number on the pieces of iron, go back and figure out what's wrong. Trust me. But no, you shouldn't have a piece of iron bigger than a real sharp pencil and so forth. But as long as you've got very little metal after this third oil change, the temperature isn't right and everything else, we consider it broken in, and then you go to the gaseous dispersant oil. Yes?
Synthetic oils.
Yes.
Do they work?
Okay, back in the 60s, Shell came up with this, let's do a full synthetic. And so we started testing a full synthetic oil. We got out, and man, it worked great. Everybody thought this was great, good starting, everything else. We got out to about 600 to 1,000 hours on a lot of these big flat engines, and all of a sudden the oil consumption went up. I'm not talking about going from 4 to 5 hours per quart, or from 5 down to 4. I'm talking about going from 5 hours a quart to 2.5 quarts an hour. I mean, it just went way down. We pulled the cylinders off, and it was like somebody had taken gray epoxy and stuck all the rings into the pistons. And what had happened, it's the lead salts. And with leaded fuels, the synthetics are very good lubricants, but they don't absorb the lead salts and can take it out of the ring belt area. So after we did that, we came out with a semi-synthetic. So then AMSOIL came out with a full synthetic, and guess what? They got into the same problem. So it was such a well-known thing that Mobil came out with a full synthetic. They even paid Continental to endorse it and say how great it was. 500-600 hours out, man, they were sitting there, oil going all over the place. So full synthetics don't work with leaded fuels. Semi-synthetics, as long as it's 50%, you know, they seem to care for the, absorb the lead, and you can get away with it. Did that answer your question?
Yes.
Okay. So, no, full synthetics don't work. In fact, we had a bunch of Rotex operators that were trying full synthetic oils, and they got into it too. Okay, normal lubrication procedures. You have to use only approved oils in certified aircraft. How often do you change oil? 25 hours, 50 hours. The most critical thing is every 4 months. That's more critical than the 50 hours or 60 hours or whatever. The less you fly, the more the plane sits, the more rouge and so forth you have in it. So a high usage airplane, in fact, University of Illinois, they fly everything about 30 hours a month, and they've gone to 100-hour oil change, and they've never had an oil-related problem. I'm not telling you to do that because a lot of these people, a lot of private pilots fly at, 50 to 100 hours a year. You still need to change it every 4 years. Every 4 months, yes. Sorry about that. I know I'm an oil salesman on, so. Change oil and so forth. Okay, now we're getting to the most critical part of the whole thing about oil. If you remember one thing from this talk, other than the fact, the first joke, I'm sure everybody's going to remember that, and so forth, you've got to calibrate the oil temperature. It's really about the only temperature indicator you have in the whole plane. But before you make sure that the thing is running at the same temperature, the first thing you've got to do is calibrate your oil gauge. We've seen a lot of oil gauges that are 20, 30, 40 degrees off. You've got to go out, so the next time you've got a free Saturday, go out, pull the oil sending unit out, put it in either an oil bath or water bath or so forth with a calibrated thermometer. Heat it up to 180 degrees. Okay, that's sort of the magic number that we want you to shoot for. And then make a mark on your oil temperature gauge. Most oil temperature gauges are just a green band. What does that mean? The low temperature on most of these is 120, the high is 240. So if you're in there, that's way too wide a band. You need to make a mark at 180 degrees. Why is 180 the right number? Okay, when oil goes through the engine, an engine's running, the oil will pick up about 50 degrees. So the oil in, if the oil in is 160 degrees, the hottest oil you're going to see anywhere in that engine is going to be about 50 degrees higher. And that's usually coming off the underside of the pistons. So if you've got 160 degree oil temperature, the hottest it's going to see is 210 degrees. That doesn't boil the water off. To get an engine to live, you've got to get it up to about 180 so it will boil all the water off. At 180, it'll boil the water off in less than an hour. So you've got to get your oil temperature up to that mark and so forth. If you get much above it, 200 is fine. If you make a mark at 180 and it's running 185, don't panic. That's fine. But you need to be around that area. Yes?
If you run it in the wintertime,
Yes.
very hard to get your oil temperature.
Yes, it is.
If you run it for an hour, hour and a half, will that get rid of the water? And you're cruising?
It depends on what oil temperature you're at. If you're running 150 and you fly 5 hours, you still probably haven't boiled any water off. You've got to get it up to above 165 before you start boiling water off. Or you'll boil a little bit, but I mean, to really get rid of the water, you need to get up that close to that 180. And you do it, sometimes you have to put a winterizing kit on it or duct tape or something like that to get it up there. But you need to make sure it's up there. Yes?
In that regard, do you have any comments on pro or con of oil separators?
The question is on oil separators. It depends on how you install them. The problem is most air separators take out the crankcase blow-by and they put it into a condensing unit, which cools and the stuff that you're boiling off has a lot of moisture in it. And what it does is it puts it back and puts it right back into the crankcase. So if you have one, you have to make sure that it's hot enough that it won't condense back the moisture that you're boiling off. We were running some tests with one, and we put a container, a 1 gallon container in there, and to see what was coming off that air oil separator. And it was the nastiest milky crap you have ever seen, and so forth. So yeah, air oil separators, although they sound good and they keep the belly clean, unless you have the condenser, the main unit out there really warm enough, you're still going to, and it's critical because you've got to get it back to the condensation temperature. It's got to be above 200, but yet it can't be so hot that it doesn't condense down the oil vapor. So I've not seen any real big advantage. It keeps the belly of the plane clean. So, any other questions on that? But like I said, if you don't remember anything else, remember that mark at 180. That'll do more than any additive, anything else. That the key to keeping an airplane alive and getting to full TBO is get the oil temperature up and fly the thing. If you do those two things and don't really mess up, run into a tree, you're probably going to get there. Then you need to make changes to hit that target. You've got to get it up there, whether it's taping it off or what. Okay, we'll run through this rather quickly. The other thing is, when a lot of people don't fly in the wintertime. And if you're going to do that, you need to change oil before you put it away. If you're going to put your plane away, don't sit there. A lot of people go, oh, I'll bring it out in the spring, change oil so I have fresh oil to start on. Wrong. You need to change oil before you put the airplane away, so you have clean oil, run it up a little bit, and then put it away. Do not run it up during the storage period, and use the preservative oil. We have things like Aeroshell 2F and so forth. If you know it's just going to sit for about 3 months, put a quart of that in and leave it set. Any questions on oil? Yes.
Is it always recommended that you change the filter when you change the oil? If you've got 5 hours on it in 4 months and you change the oil due to that time limit, could you just change the oil and leave the filter in?
I don't really have any data that says positive. Probably it wouldn't be that big of a deal to leave the filter on. We have a lot of people go, I fly 5 hours a year, what do I do? Save up money for a new engine, I guess is about the only thing you can do. One quick thing on grease, when you're greasing it, in your owner's manual, it will tell you what grease by mil spec, and that's the only grease you can use. One of the problems is if you just use grease, most greases aren't compatible, and you can end up with a real soupy mess. And one last thing is, everybody likes a clean airplane, but don't power wash your airplane. Because what happens is if you hit wheel bearings or bearings, that high pressure water will be forced past the seals and you'll start corroding your bearings. So a clean plane is not always a good plane. Okay?
Thank you, Ben, very much.
Thank you.